This truck's half axle broke due to severe overloading by the owner. Under normal circumstances, it would likely be sent to a scrapyard. However, in Pakistan, due to material shortages, expensive parts, and cheap labor, any problem that can be solved with a lathe and welding is no problem at all. Since the fracture surface of the half axle is shattered, gluing it back together is out of the question. Direct welding would also fail to meet the quality and size requirements. But for an experienced Pakistani craftsman, these issues pose no challenge. Before starting the repair, the craftsman carefully measures the broken axle and marks the cutting points on the fracture surface. The purpose of this is to precisely mark where to cut. After thorough measurements, the craftsman selects a similar discarded half axle from India to use as a replacement. This not only restores the axle's original length, but also maintains the overall strength. After marking, the flange end is fixed on the lathe, and the craftsman uses a lathe tool to cut off the excess material, paying special attention to avoid the fracture area and ensuring that the section with ductile fractures is completely removed. Every layer is carefully inspected to make sure there are no cracks, ensuring that this section of the shaft can still be used. To ensure that the two sections of the half axle align perfectly during welding, the craftsman drills a hole in the center of the shaft for the connection. The hole is further expanded using a twist drill. Once the hole is processed, threading is done inside the hole to ensure a strong joint and to maintain concentricity. This makes the joint even more secure. Once the threading is complete, the flange end is ready. The same process is then repeated on the other half of the axle, trimming the torn fracture surface and drilling holes. After each cut, the craftsman uses a caliper to check the hole diameter to avoid any size discrepancies. Once both halves are prepared, the craftsman fits them together and measures the total length against the original axle length. The difference in length is the length that needs to be added to the joint, including the depth of the connecting hole. After precise measurements and calculations, the replacement half axle is secured on the lathe. Since both ends of the original half axle already have step joints, the replacement axle must also have matching steps. To ensure both ends align correctly, the craftsman takes precise measurements with a caliper, and once the dimensions are confirmed, the external threading is machined. The craftsman applies marking paint on the contact surface to monitor the threading process and prevent any discrepancies. Once the threading is complete, the three sections of the half axle are ready for assembly. The threading is smooth, indicating that the machining was flawless. After assembly, the lathe is used to check the overall concentricity of the axle. Once verified, further machining is done to create a bevel for welding. After machining the bevel, the craftsman uses a welding rod to perform the build-up welding at the bevel. Once the surface slag is removed, the bevel is gradually filled with weld metal until it is fully covered. Since the weld beads would affect the appearance, the excess is machined off to ensure the surface is smooth and flush with the original shaft diameter. After the entire surface is smoothed out with no visible traces of the repair, the half-axle replacement and repair are complete. What do you think of the craftsman's skills? If you were to rate them out of 10, how many points would you give?